In this section, we're jumping up in sides to quadrilaterals and then other polygons, triangles, quadrilaterals, and any shape, 2D shape that is made up of 3 or more line segments are known as polygons. So a triangle with 3 sides has 180 degrees in it. A quadrilateral, squares and rectangles and such, have 4, trapezoids have 4 sides, 360 degrees. A pentagon has 5 sides and has 540 degrees within the sum of the angles. A hexagon, 6-sided, like a stop sign, 720 degrees. And then an octagon is 8-sided with 180 degrees. I skipped the 7-sided septagon. I think it's called septagon because, one, I forget the name sometimes, and we don't often use them. Generally, we use triangles, quadrilaterals. We'll see pentagons often. They fit with the whole concept of a star and things like that. People use them as pentagrams and things, so they're kind of common shapes that we'll see. And they also kind of fit the house shape as well. These here, these ones I was trying to go for more of a regular type shape, but they can be this shape, and just like a quadrilateral could look like that. Doesn't have to be equal, all the sides equal, as long as they have straight line sides and they are all connected and enclosed. So these are the common ones. There's other names for other shapes, just you don't need to know all of them beyond this in general. Anyways, the total angles, if you want to know why they add up to these, well, we know a triangle has 180, and using that as our base, if we divide up any of these shapes into triangles, so here I have a hexagon, so 6 sides, we divided that up into triangles. So I drew a triangle here, and then I drew one here, so I had the 2 ends, and then if I cut that rectangle in half, I get 2 others. So I got 1, 2, 3, 4 triangles. 4 triangles, well, each triangle has 180. 180 times 4 is 720. And later I'll show you the formula that we use to do this. And you can do this with any shape. You can chop it up. You can take this guy here, chop him up into triangles, and add up the triangles inside. Now, so polygons, if we have a regular polygon, all that means is that the line segments are all of the same length. So a square would be a regular quadrilateral. Otherwise, a rectangle or any other, and that would be irregular. Moving on. We can use these to determine the missing angles. So here we have a 1, 2, 3, 4, 5, 5-sided shape. And we even have an external angle out here. We want to find these missing angles. So a 5-sided shape is going to be a pentagon. Pentagon is going to have 540 degrees within it. We can also use the formula, which I mentioned earlier. The sum of the angles is just 180 times the number of sides minus 2. So the sum of these angles, again, 180 times 5 minus 2, or 180 times 3, which is going to be the 540 degrees. So the total of all these is 540 degrees. I'm going to just give an X and a Y to label these. So to find X, that's easy. This is a straight line. 180 minus 85. So X equals 180 minus 85, which equals 95 degrees. So X is 95 degrees. And then to find Y, well, the sum of all these angles inside is going to be 540. So Y equals 540 minus 110 minus 170 minus 100 minus 95. And so when I do all that, 540 minus 110 minus 170 minus 100 minus 95. That's going to give me an angle of 65 degrees. So there's my X, there's my Y. And now I have my missing values. And you can do that with any of your polygons. Just use that concept of how the sum of the angles inside, or the idea of the exterior angle being 180 to find missing values.